Okay, so we are on Unit 1, which is software reuse. So just to give you an introduction into this unit, software reuse can be defined as a process of using an existing system, component, object, or function to develop a new system. Increased demand and prolonged time to develop a software has led to most organizations to demand the idea of reusing software. The reused software is reliable since it would have been tried and tested. It's cost effective than developing a whole system from scratch. Modern software requires dynamic and swift solutions. Back in the day, you could go about developing a software yourself from scratch, but with modern software, it becomes unsustainable. So you need to find ways, and I hate to use this term, but in terms of reality, you need to find ways to cut corners. And in terms of when we do anything, when you're manufacturing anything, cutting corners seems to sound like a bad idea. But when it comes to software reuse, it's actually not that much of a bad idea. It's actually better. And I'll tell you why in the later slides. So in this study unit, these are the following learning outcomes. Have a thorough understanding of the benefits and problems of reusing software during systems development. Have a comprehensive understanding of the application framework as a set of reusable objects and how the application framework can be used during application development. Have knowledge of software product lines, which consists of common core architecture and reusable components which are configured for each version of a software product. Apply and formulate how systems can be developed by configuring and integrating commercially off-the-shelf software systems. Okay, so just to provide some context, the term software, what did we say it means? So it's any set of machine-readable instructions that direct a computer's processor to perform specific operations. Software is a generic term, a general term. It can refer to all computer instructions. It is inclusive to both machine instructions and source code. And we know that we can further divide software into two main categories, which is our system software, and then you also have application software. System software, our operating systems, and our utilities, such as your antiviruses, all of those are system software. And then we have application software, which allows us to perform certain tasks. So what is then software reuse? So software reuse can also be referred to as code reuse. Although this term code reuse doesn't actually describe the different levels of reuse. If you say code reuse, it's very tempting for someone to think that we're actually just copying and pasting code from one project to another. But it actually goes deeper than that, okay? When you're talking about code reuse, you tend to think, okay, the person is just talking about reusing a particular object, but this thing can go higher, even reusing an entire system, okay? So the term code reuse tends to limit the whole concept of software reuse, but we tend to use the terms interchangeably. So code reuse can be described as the use of existing software to build new software for an individual or an organization. Software engineering has become more focused on original development, but it is now recognized that to achieve better software more quickly and a lower cost, we need to adopt a design process that is based on systematic software reuse. So the whole discipline of software engineering, it has moved away from original development because of these new requirements of software that we build in this expect software to do this particular or have these particular features. So you can't limit it to original development, because then it means that you need to define the scope of work from scratch. Okay, so you need to move away from original development because it's unsustainable in terms of modern software. We are faced with trade-offs: time, cost, quality. All of those become trade-offs when you're building modern software. So by adopting software reuse principles, it means that you are able to strike a balance between those. Okay, and with original development, you're just killing yourself because you want to do everything from scratch. And why do that when you can actually take corners, or sorry, cut corners? And when you're cutting corners in terms of software reuse, you're actually adopting something that has been used before by other vendors, and it has been tried and tested. So it's not that you are increasing the risk by cutting these corners, but in actual fact, it's in the opposite direction. Original development is the risky one because you're the first one to write this code. It hasn't been tried and tested. It means now you have to go through the whole testing phase, and even then it's not that reliable. Okay, so with software reuse, you're getting components that have been used in other softwares and from vendors that are very reliable. So it actually it's more it improves on quality, on the aspect of quality. So what are some of the benefits of software reuse? Of course, we say it is cost effective because it lowers the scope of work. From project management, we know the project triangle. We say cost, time, and scope are related. If you change one, it means it has an effect, a knock-on effect on the other ones. So by saying software reuse reduces the scope of work that you need to do, it means in essence that you want to be saving on costs. Okay, so it saves on costs. It saves in the same manner it saves on organization's time. It also produces high quality products. Okay, going back to less errors because you're using components that have been built by other vendors. Okay, and then also you're able to become compliant. You become compliant automatically in terms of standards, because then it takes away that responsibility from you as a development team, because somebody has already done that for you. Okay, when a component is released to the market, it's already been tried and tested, it's already gone through all of the standards, organization checks, and so forth. So those are some of, or these are the benefits of doing this software reuse. So what would then be the disadvantage of software reuse? We say lack of innovation. Developers no longer become creative or come up with new ideas because everything they're building is not originally from them. It's coming from, they just write just a couple of the code, but most of these components are coming from different sources already, and their job becomes purely integrating it into the wider projects. Okay, so lack of innovation. One thing we can say about original development is that people were able to innovate or come up with new ideas of how to build things. Also, one thing you got to remember that we're living in an era where standards mean a lot. Standardization is a big thing. When you're building an app for a phone, you want to build it so that at least it mimics or looks like other apps out there. You don't want to be building something, you don't want to innovate too much, okay? You don't want to be building something when a user is moving from another developer's app and they come to your one and they become confused. So we are actually living in an era of standardization. And that's one of the reasons why people tend to favor software reuse, because you're doing it makes it easier for the users to be able to adapt and start using your software, because your software mimics something that has already been done somewhere else. Okay, so the fact that it lacks innovation may not be so much of a bad thing, because that's the whole point. As much as we want to innovate, but we're also trying to do things similar to how other people are doing them out there for the sake of our users. And maintenance is costly. Remember, you don't own these components that you are reusing. You get them from an external vendor, which means now when you are maintaining your software in the organization, it means you're going to need to bring in people that are specialists who understand those particular components well, and they're going to have to help you out with the maintenance. So it could be very expensive because you could have developers in-house, but none of the developers are experts at that particular or changing or they may not even have the rights to change the code to those particular components, okay? So those are some of the complications that could come with maintenance. And then lack of tool support. So all our computer-aided systems engineering tool sets that help us to design or implement these softwares may not be capable of, or they were not built for software reuse. They were not built for the purpose of integration. They were built for original development, to support original development where developers are writing code from scratch, okay? So these are some of the disadvantages that you're gonna encounter. So what are the different types of software reuse? We have software reuse at the highest level, okay? Reusing systems of systems. And this means that the system, you're reusing the whole package or the whole ecosystem, okay? You're reusing the whole ecosystem. When you talk about application reuse, the difference is that you're using a specific application within that ecosystem. And what you're actually doing is you are taking that application and you're integrating it into your existing ecosystem. And component reuse means that you are taking a particular component or a single object and you are reusing it. And then we have at the smallest level, objects, okay? Or functions rather, okay? And this is the one at which you can refer to as code reuse, because it's like taking code that controls the functionality of a click event handler for a button. You're copying it and you're pasting it from one software to the other. That's a prime example of function reuse or object reuse. At the smallest level, it's the object. Then at a level higher, it's the components. And at the components level, maybe it's the whole login form. Okay, that's the whole login form that you are reusing. At the object level, it's just the login button. So some of the questions you may be asking yourself when you're considering using software reuse: how much time do we have? Okay. You may favor original development if you have enough time, but realistically in industry, your customers put pressure on you. So by default, you tend to favor software reuse. But one of the questions you're going to ask yourself, how much time do we have to develop this solution? For how long are we going to support the software? Okay, the software's lifetime. The development team's experience. Okay, we're going to be sourcing all of these different components. Do we have people that are capable of integrating it? We have knowledge in these particular components that we're going to be reusing. How critical is the software? If it is mission critical, then you may wanna outsource or definitely favor software reuse, because remember that original development comes with issues. You're the first one to do it and it hasn't been tried and tested in the market. So you're definitely bound to encounter some sort of issues. So if you're talking about mission critical systems like banking software, aeroplane reservation systems, hospital systems and stuff like that, those are would be mission critical systems. So something like that, you don't want to play around with it and do original development. Just get the experts that already have something out there and do reuse. Also, you want to ask yourself about the particular application domain that you're in. Maybe the application domain that you are in, or the problem that you are facing in your organization, it's so unique that you definitely have to do original development. You don't have a choice. But I mean, if you're in the spheres that I just mentioned, you are an airline, you are a hospital, you are a bank, there is definitely, to some extent, something out there for you that you can reuse, okay? And the platform of the system as well. Just to give you another example, let's say you wanted to build an e-commerce website, okay? Now, there are other vendors out there that can help you quickly drag and drop and build an e-commerce website, but you want some level of customization for your e-commerce store. So you say, okay, we're going to use a blended approach. We're going to combine original development, and we're also going to do reuse for mission critical components. So you can have an approach where you blend both, okay? And let's say now you are working on the checkout feature. So the checkout feature is one example of a mission critical component of your system, and you're not gonna be coding that facility to process the transactions yourself. You're gonna be using a payment gateway. Maybe you're gonna integrate something like PayPal, okay, for that particular checkout feature on your e-commerce store, so that you blend these two, okay? You know, PayPal has been around for a long time, and they've been doing this for a long time, and their stuff has worked for other organizations. So by doing that, you are not compromising the standard of this particular mission critical components for your website. And there are several approaches that you can use, okay? There are several approaches that you can use when doing software reuse. As you can see, let me just take you through some of them. So we can use application frameworks, okay? And these application frameworks is just a combination of UI components. The developer still needs to write code to sort of define how they operate the functionalities. Just so application frameworks consist, mostly found on the web, but they consist of objects, components that developers need to write functionality for. And application systems integration. So that's another approach. You can integrate multiple systems together to create a new system, okay? So it's when you integrate two or more applications. Architectural patterns. And again, this is not something that's coming up for the first time. So you guys should know what architectural patterns are by now. And when you're doing this type of approach to reuse, we said it's reusing knowledge, okay? You're reusing the architecture. It has nothing to do with the code. It's just reusing the knowledge about the system. And then aspect-oriented software development. They said shared components are woven into an application at different places when the program is compiled. So this type of reuse, the components are actually integrated together at runtime, okay? And then in contrast, this components-based software engineering that's what it is. It's reusing components. It's not at runtime. You integrate them locally in the local development environment. And then we also have configurable application systems, and these are domain-specific systems that are designed so that they can be configured to the needs of specific customers. You can also reuse design patterns. All our UML models, such as the use case diagram, the ERP, and so forth. So we can reuse the ones that was covered in chapter 7. You can reuse your design patterns, and ERP systems is an example of systems of systems reuse at the highest level, okay? Because remember what ERP systems do is they take the existing ecosystem and they encapsulate it or put everything in one particular layer, and you can access all the organization's data and including additional business functionalities through that one ERP system. Then also legacy systems wrapping is another example of reuse. Let's take a legacy system that already exists in our organization. And this was first semester in one of the chapters, chapter 9 in first semester. Let's take this existing legacy system, let's improve on it, let's add additional features. That is reuse, okay? You're taking something that already existed over a number of years. And also model-driven engineering we spoke about in chapter 5. And this was a typical example of reuse because we separate the layer that defines the functionality to the layer that speaks to the design. And by doing so, it means we're able to separate the functionality alone and reuse it in a separate project, okay? Because only the design is platform specific, right? And then we also have other means of or other approaches to software reuse, program generators that generate piece of code for you. Maybe you want a particular code for a button that maybe verifies a text box if it's an email address, and that program generator will sort of generate that code for you. So that is an example of code reuse because someone else wrote that code and you're just using this program generator to copy and paste it to your particular project. Then we have project libraries, service-oriented systems, software product lines, which we talk about in a later slide, and systems of systems, which are already mentioned to you. So these are different approaches that exist. You can see it's a very comprehensive, a wide variety of approaches that you can adopt. So in terms of application frameworks are a collection of abstract and concrete classes that are adapted to create other application systems. These frameworks usually consist of predefined UI components, and software engineers just have to code the functionality. Some examples of this is we have jQuery. You may have done web development, you should have done web development already in second year. And from what we know, in terms of web development, HTML is very static. And we need to use some sort of JavaScript to make it a bit fancy, okay? CSS and JavaScript together. Now, let's say you are faced with a scenario where you need to show a gallery. You need to show a gallery on your website, a gallery of, we have a slider of moving images, and these images have to change every 5 seconds, okay? You've seen this a lot of times on websites. Now, that is done by JavaScript, okay? So jQuery is an example of a JavaScript-based application framework, which means if you wanted to implement a particular feature on your website, there's probably a jQuery plugin that already exists for that feature, and all you need to do is download that plugin, and there are some sort of configurations that you do, but as a developer, you shouldn't struggle with that. So all you do is do the configurations, and once you finish setting up everything, hence they call it a plugin, then your gallery should function with you doing minimal work, okay? Now, that's a typical example of a application framework because it saves you time. You did not, if you had to code that feature yourself, that gallery feature yourself, it will take you days and days and a lot of lines of code. But since something already exists out there, we just adopted it into our particular project. So we have jQuery as an example of an application framework. There's also Bootstrap, which is owned by Twitter. They also have a framework which it's open source. They allow developers to sort of use their components, some of the components you see on Twitter, the UI components. And we have also components for or reuse or application frameworks that can work for Windows Forms. So it's not only web-based technologies that have these application frameworks, but also for Windows Forms. There are particular application frameworks that you can use for Windows Forms as well. When you integrate these frameworks into your Windows Forms, then they come with additional features or a new look and feel, and then you just need to customize the functionality behind them. And also this material design is an example of an application framework for mobile development, Android to be specific. So if you don't want to write certain functionalities of the Android application yourself, you can download this material design, which already comes with some functionality, or but main thing, it brings you additional UI components that you integrate into your project, and you're able to save time in the process. So software product lines. A software product line is a set of applications which contains shared components with a common architecture, and each application reflects a specific user's requirements. Now, product lines, let's for a moment forget about software. Product lines are something that are common to multiple industries. Okay, let's look at the way they manufacture cell phones. We have iPhone, the iPhone 7. Then the following year we have the iPhone 8. Then the following year we have the iPhone 9 or 10 or whatever. Now, going from iPhone 7 to iPhone 8, there needs to be something that the developers would have wanted to change. Maybe they want to improve on the camera. Maybe they want to add additional security features and a fingerprint scanner and so forth. But the idea with product lines is that the core business logic, the architecture, or the components are shared, okay? They come from the same family. So it doesn't matter if you have an iPhone 7 or an iPhone 8. Sure, they look different here and there, and the other one has a better camera than the previous one. But you got to understand that they come from the same product line, which means they share core assets, okay? So same thing applies when you're talking about software product lines. Look at it from the terms of Windows. Windows is a product line because when you're going from Windows 8 to Windows 10, it's still the same .NET framework architecture that is there. It doesn't lose its architecture. But on Windows 10, obviously, we want to have additional features that are added to the software, okay? So we have, that's a great example of reuse, because when they go from Windows 8 to Windows 10, I don't think there was a Windows 9, to Windows 10, they didn't reinvent the wheel. They said, okay, Windows 8 this is what's good about it. So we're going to take it, we're going to change the user interface. Oh, we might replace the browser for Internet Explorer, and we add the start button again. So in that sense, you are looking at what kind of feedback your customers gave you, and you're improving on that. And you have now a new product line where you reused source code that was already existing without compromising the core architecture of the software. And software product specialization. So you can become platform specific, where you're creating a version for each platform. Okay, you're creating a version for each platform that exists. So we have Android, we have iOS, we have BlackBerry. We want a version of our software for all of those platforms. And then when you talk about environmental specialization, it means that it doesn't matter which version the user is using. There has to be some sort of cross-platform communication happening. So it's not to say that because you have an Android device and you have WhatsApp on Android, then you're only able to communicate with Android users only. No, that's the difference between platform specialization and environment specialization. It means in terms of the communication aspect, although they're on different platforms, but can your system still communicate with the same clients on a different platform? Okay, and then you also have functional specialization. So different versions of the application are created for customers within different requirements. And you also have process specialization. Different versions of the application are created to support different business process. I think these two sort of explain themselves. And what is the difference between, the main difference between a product line and an application framework? Okay, we say an application framework use object-oriented features such as inheritance and polymorphism to implement an application, and the code cannot be modified. And if you can modify, you will be limited in what you can do with the code. Whereas software product lines components can be changed, deleted, or even rewritten. So when it comes to application frameworks, you are using someone else's framework into your particular application, so you are limited in the amount of, you just take it as it is and you use it. You're limited in the number of changes that you can make to the particular components. All you can do to it is add the functionality, okay? But with software product lines, most of the time a software product line, you own it, okay? Microsoft owns Windows, they owned Windows 8, they're also gonna own Windows 10. So what they do with their product line, it's up to them and the extent at which they make the changes. So it's very common in software product lines to see things being changed, features being deleted, and features being rewritten, okay? It's at their discretion. And then application frameworks offer generic support, whereas software product lines are domain specific since they embed domain and platform details. Okay, so that's the tricky part about software product lines. It's more of a localized thing to say, this is based on this particular framework, the .NET framework. It has an embedded domain and it has platform details attached to it, as opposed to application frameworks. Okay, with application frameworks, they target the most of them, not all, but most of them are built on web technologies. And the purpose of that is to make them as generic as possible. You don't want them platform specific because we view the web as this generic environment or platform that all the devices, regardless of who owns them, can access this particular platform. So application frameworks in nature are more generic and they implemented using, anybody can consume, any device, modern device can send requests using HTTP and so forth. So application frameworks are service oriented. That is, they don't include hardware interaction components, whereas software product lines control applications and the environment. Again, thinking about it from the perspective of looking at Windows as an operating system and as a product line. It has the ability to control applications, and it's an operating system, so it controls hardware as well. Whereas application frameworks are more of service orientated, okay? They work on the web using HTTP and so forth, using web technologies. And then lastly, software product lines use generic core application, whereas an application framework don't use generic core application. That is, you start by creating the closest member in the application family. So we also have, so software reuse is good if you are building something, if you're building something from scratch, okay? We have that option of original development, or software reuse. But you may just buy the whole system off the shelf. Sometimes there may not be a need for you to build anything because the solution already exists. And an application systems product is a software which can adapt to the needs of different customers. In other words, it is a generic system, and this should be done without changing the source code. You don't have the rights to change the source code for these application systems. So these systems are also referred to as commercially off the shelf. And examples of such products include our Microsoft Office off the shelf. All you need to do is buy a license, and then you start using it. You don't get to make changes to it or the source code. We also have Sage Payroll, and we also have Adobe Suite, and then you also have SAP. Okay, these are commercially off the shelf systems. So, in conclusion, this study unit gives detailed information on how systems, components, and objects and functionality may be reused. Reusing software has its own benefits and problems associated with it, which we outlined. Some of the benefits are low costs, the lower risk associated with the development, and a system can be implemented within a short period of time. Okay, so that is study unit, and it covers the concept of software reuse. Okay, do you guys have any questions regarding this study unit?